So this is a lightweight rod, and it contains this 2 kg 2 kg mass and 5 kg mass. So I want to find out the actually in initial stage it was horizontal. So when I am going to leave it, let's check what will happen. So my torque will be for 5 kg 5 into this is L by 2 minus 2 into L by 2, and this rod will rotate in this direction I alpha. 3L by 2 is equal to I alpha. What will be the I for this one? 5 into distance L by 2. This is the angular acceleration. 5 into r square, that is L by 2 square. And for this one also 2 into L by 2 square alpha. 3L upon 2 is equal to 7 upon 4 L square alpha. So we have to put G also. 5G, 2G, I alpha G. So 6G over 7L. Okay, so this is the angular acceleration that will be generated. Now I will show you another example also. This is a disk. Its moment of inertia is I. Initially it was rotating with the angular velocity omega naught, and it comes to rest after t time due to some friction. This is rotating around this axis. Due to some friction here between the axis of rotation and the disk, it comes to rest after t time. So I want to find out the total work done by this friction in stopping this wheel. So as we know that half I. So this is the total work done in stopping this. Total work done by the. This is the total work done by the friction force in stopping this wheel. Now I also want to find out what will be the torque applied by the friction force in stopping this wheel. So as we know that tau is equal to I into alpha. So what I need is alpha. So initial velocity was W naught, and after time t minus final velocity becomes 0, and after time t it was. So alpha is equal to omega naught upon t. So torque by friction forces in stopping this wheel, I omega naught upon t. There is another problem also, like the initial velocity of this cylinder was W naught, and there was another cylinder also that was initially 0. So I want to find out the time t, like when it will come in contact with this cylinder. So this cylinder will start deaccelerating and this will start accelerating with the angular acceleration alpha. For this alpha is the deceleration, and this alpha acts as an acceleration for this. So I want to find out the time when they both have the same angular velocity. So for this one, this will be like let's omega be the final velocity. So for this one, this will be omega naught minus alpha into t. And for this one, omega is the final velocity, is equal to 0 plus alpha t. So I am going to put it here. Alpha t is equal to omega naught minus alpha t. So t will be omega naught over 2 alpha. So after this much of time, both will have the same angular velocity. Thank you.